For the next four problems, number 10 through 13, I am going to set the equation up for you that what you're going to be using and allow you to go through and solve. And you can just look at the answer key that I'm going to post for the study guide to make sure you solved it correctly. Number 10, the value of a motorcycle is depreciating by 2.8% each year. The bike was purchased for $12,000. How much will it be worth in 12 years? So depreciating at a rate of 2.8, initial cost of 12,000, and the time period is 12 years. Depreciating tells me we're looking for a decay formula, and the decay formula is the y equals the amount of the total investment or total initial price, and 1 minus the rate as a decimal raised to the power of your time. Again, I just want to set you up with the values, and then you can go back and write the formula out and solve. The A is 12,000. The rate is 2.8%. Move it over twice. Will be 0.028, and the time is 12. Go ahead and write it down, solve it, and again, you can come back and check for the final answer. Number 11, Hannah borrowed $4,000 with an interest rate of 5% compounded monthly. How much will she owe after 5 years? Compounded monthly and interest rate. If you're borrowing and you're having compounded monthly interest, then you're going to use a compound interest formula, which is A equals the principal times 1 plus the rate divided by the number of times it's compounded and raise it to the power of n times t. And the principal in this is 4,000. The rate is 0.05. The number of times compounded says monthly. How many months are in a year? 12. So my n is 12. That looks like 72. Let me fix that. And the time in years is 5. Set it up and solve it. And let's look at the next one, number 12. Robert wants to deposit $600 in an account that earns 9% interest compounded annually. So $600, 9% compounded annually. How much money, rounded to the nearest cent, will he have after 2 years? So let's look and see what we're given. We see the word compounded and annually, compound interest formula. A equals P, parenthesis, 1 plus R divided by N, NT. Principal is going to equal 600. The rate, 0.09. The number of times compounded, well, annually means once a year. So the N is 1. And the time is after 2 years. Okay, so go ahead and solve that. Come back, check the answer. Let's get one that's a little different. This time we are asked to find which is a better investment. 9% compounded monthly or 9.3% compounded annually. All right, so for this, let me just go ahead and tell you. To see which one's a better value, you just need to pick an amount that you want to invest and then compare the two. So I want to pick 1,000. It's a really easy number to work with. So write this down. Just pick an amount. But you need to pick the same amount for both of them so you can compare. Pick an amount. And I'm picking 1,000. If I want to see if 9% compounded monthly is a better deal, I'm going to take the 9% and I'm going to write out the formula for that, which is A equals, and I'm just going to go right to the principal, which is 1,000. And since it's compounding it monthly, there are 12 months in a year, I've got 1 plus, forgot to put the 0.09 first. My bad. 12 months in a year, so that's going to be that over 12. And then raise it to 12 times, well, 12 times 1, I guess, or just 12. When I do this, I'm going to end up with an investment of $1,093.81. Now, the 9.3% interest investment, I'm going to use the same numbers, 1,000, but this time the percentage is different. So it's 0.093 over annually means once a year. And I'm going to raise it to the power of 1. I can just say times 1 year as well. When I work this one out, I'm going to get $1,093 exactly. Which one am I getting a better deal for? Well, not much, but the 9% monthly loan is going to come out to be a better deal. And instead of posting an answer key, I'll just go back and write the answers for number 10, 11, and 12. That way, once you're done, you can pause and just check. But the answer for number 10, you should have $8,534.47. For number 11 is $5,133.43. Number 12 is $712.86.